All right, so for the assignment where we're trying to plot essentially a titration curve, right? Um, this is what our curve should look like here. And I don't want to click on these equations because I kind of want you to struggle through them and learn how to get them to work. But essentially, hopefully in the end, what we have is a system where we can put in the amount of base in terms of milliliters that we start with and concentration, and the concentration of our titrant, acid that we're going to be titrating in. And the equations, I mean, ultimately, this here is the equation that identifies what the pH is, and this plot here is just pH versus volume of acid. So here's the volume of acid. I've just, you just type these numbers in, 0.1, because we decided to do 0.1 milliliter increments, okay? So this is a plot of the milliliters of acid versus pH. Now, in the beginning of a titration, the thing that governs the pH is simply the amount of, in this case, base that you start with. But then as you add acid, the concentration of acid goes down. Sorry, as you add acid, the concentration of base goes down, and therefore the amount of base decreasing changes the pH. And so all of these numbers, all these values here, are governed by the concentration of base, essentially. As soon as you run out of base and there's no acid or base, this is the end point, and that is going to be the pH at that point is going to be governed by the conjugate base of our weak acid, our acid that's left over, or if there's any base, the conjugate base, or I should say not the conjugate base, but just the base that remains from any weak acid. So in this case, because we're working with strong acids and strong bases, it's going to be right at 7. So there's nothing left over. But if this material here, as it's titrated, if there's a resulting conjugate acid, or if we work with a base and then an acid and titrate it to a base, the resulting conjugate base, so either a conjugate base or conjugate acid, governs that pH. So essentially the only thing that's there at that equilibrium point, the end point there, is the remaining ions from the salts that you use. And if any of those ions are weak acids or weak bases, then that needs to govern and needs to determine what the pH is. So you have one equation for all of these plot points, one equation there, or in this case we don't have an equation, you just type in 7. And then there's another equation for all of these points. So there's 3 equations. All right, and to help you kind of visualize a little bit better, it might help to have columns like these. They don't need to be exactly like these, but this kind of helps. It's hard for Excel to know order of operations very well, and I don't delve deeply into to understand what it's thinking when it does its calculations. And sometimes I just put in a lot of parentheses, and I think it's supposed to follow the parentheses, but I can't always see that it is, and you get so many parentheses, sometimes you lose count, so it becomes easier to just break it up into different columns, and you don't need to use ones like this, but I found that these ones were helpful. All right, so this is what the result should look like, but again, I'm more interested in what your resulting equations and how you parse it up to make it work out the right way. And if the variables for these equations, for this is the only one that really has the equation, but these also are kind of equations because they're dependent on the units that I put in here. So theoretically, if I made changes here, you still have to make some changes down below here, but theoretically we should be able to make a minimal amount of changes and just change the concentration of acid or the amount of base, that we start with. All right, take a stab at this, see if you can get it to work.